Taylor, where did we leave off at from yesterday? You're saying hardness?
Talk about hardness, and you weren't really good at writing anything down.
Okay. So just kind of a quick deal about hardness. What is hardness then in referring to substance, like a physical property of a substance?
How hard something is, and how strong something is.
Okay, how hard it is, how strong it is. What's something that would be like a really soft metal?
Oh, I was going to say marshmallow.
Oh, true, marshmallows are soft, but like in terms of metals, what's a really soft metal? Huh? Copper's a softer one. It's not the softest, but it's a softer one, yeah. Aluminum's generally pretty hard. In fact, from here, I'll mention one thing. In terms of hardness, they say, as part of the paragraph here, one way to compare the hardness of two materials is to see which one can scratch the other. The blade of a typical kitchen knife can scratch copper, it can scratch copper, a copper sheet, and then because the stainless steel in a knife is harder than copper, but copper can't scratch the stainless steel. Or diamond. Diamond can scratch just about anything. It's one of the hardest materials that we have. In fact, it says some of the grinding wheels used to sharpen steel contain small grains of diamond. So the way you can test hardness is by taking two objects and seeing which one scratches the other. That's how you can determine which one is softer of the two. Okay?
Make a nice musical sound.
Sure. Or you can also do that with like liquid glasses, and you can fill them up to different levels. Ding, 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 ding. Make yourself a little xylophone or bells or whatever. Okay. Now, water. Now, right now, obviously, you say, oh, this is just water. Well, guess what? Water can be this. Water can also be two other things. And it's still water. Aaron, I see the light bulb. What is it?
It can also be ice, and it can also be like a gas form.
Exactly, yeah. It can be ice. Like now, granted, today's not the ideal day to show that, but I tell you what, the way the weather might be tomorrow, we might see some ice. Hopefully we don't. Well, guess what? If there is,
We're in June.
you're into June.
I thought we were.
And if you're into June, uh-oh.
I know snowman.
Don't think about skipping that last day. I'll have a test on that last day. You want to skip a test on the last day?
Yeah.
Two Frank's like, yes.
Of course.
What am I doing?
No, I would skip.
Trimester test, huh?
What if you're throwing up?
Well, then you'll have to come in later and make it up. That's the way it is.
When? Like in the middle of the summer? Or
Huh?
when would you do that?
What?
To make it up?
You'd have to come in. You'd have to come in as soon as you're well, because I wouldn't be able to turn in your grades until you're done with that.
Hi, you have extra school time.
Or we'd just give you an F for it.
That's just rude if you like.
Well,
drive
then you come in and
you
make it
out of
up.
your face.
We come in and make it up. I'm just telling you right now what the policy is.
So you really do have a test last day of school?
Usually what I do is the last day of school itself is like a partial day. So what I do is I often have a test on the second to last day, and then if those that aren't finished, usually that last day, which is like a half a day, you have time to finish it up that day. So, But anyway, getting back to this, I know we drifted off topic there, but of course all related to ice. Water can be a solid, liquid, or gas. So, how is it that we are able to change water into a solid? What do we have to do? Okay, at what temperature does that happen for water? What's the temperature at which water freezes, gang?
32.
32 what?
Fahrenheit.
Degrees Fahrenheit.
0 degrees Celsius.
Thank you, 0 degrees Celsius. Very good. That's a lot easier to remember, in my opinion, is 0 Celsius. Think about it. 0 is freezing. So let's stay in Celsius for a moment. Okay. At what temperature does water boil? 100. Here's a tough question. because usually not everyone knows this. What temperature
So,
does water boil at?
120,
No,
300.
no,
no, it's like, it's not that high. Like 60 something.
no.
It's like 80 something.
100 degrees Celsius, yes. See, everyone remembers Celsius, and darn it, that's why we should switch to Celsius. It's so easy. 0 is freezing. 100 is boiling. Huh?
Why change it now? We've been doing this for a while.
Wait, so technically our
Because we're only one of 3 countries in the world that doesn't go by the metric system. The metric system is so easy.
Or smarter than
Well,
them.
we're learning this.
I would totally argue that point.
Hey.
It's like changing our language to a cat.
But I mean, I always find this. I found this question to be true every year, and it's no offense to you guys because you're not used to working with boiling points. Almost everyone can usually tell me. Usually everyone can tell me the freezing point in Celsius and the boiling point in Celsius, and they can tell me the freezing point in the Fahrenheit. But usually no one can tell me the boiling point in Fahrenheit.
275 degrees.
132.
Let me look it up.
No,
Shoot between those
What'd you
two.
say, Chris?
132.
132 and accent, so it's like
275.
It's like
200.
220.
You're close. You're close.
212.
Cheater.
Yeah.
212. That's
Still
easier
not
than just
answering.
212.
No, not really. It's a rather random number if you ask
Yes,
me.
2 minus 2.
David, we'll get into this a little more next unit as to how the Fahrenheit system was made and how the Celsius system was made.
I don't remember that now. I
So-
never heard of it, so.
Yep. Yeah, it's very rare that people remember what
I
the
would've
boiling
guessed
point
100
Fahrenheit is.
Celsius, but
Yeah.
I would've-
And that's how really the Celsius system was founded. 0, freezing. 100, boiling. But anyway,
Yes.
we'll talk about that a little more.
So 50 is the temperature?
No.
Why?
50 is pretty warm in Celsius.
What would that be?
What is it?
Okay.
I want it to be about.
So to convert, you take 9/5 times 50, so 110 times 9 is 90. 90 plus 32 would be 122.
Yeah.
Oh, that sounds pretty nice.
No, not then.
100. So it may get that hot in Phoenix in the middle of the summer.
Yeah, it gets pretty hot there. It's been there.
Even 30 Celsius is pretty warm.
I'll go more 15 then.
What's 30?
6 times 9 is 54. 54 plus 32 is 86.
I'll go 15.
I
So
like
30 degrees
37.
Celsius is 86 Fahrenheit.
Sorry, Steve.
20 degrees Celsius, 4 times 9 is 36. 36 plus 32 is 68. So, in fact, 20 to 22 degrees Celsius is considered room temperature, which would be about the range of 68 to 72 Fahrenheit.
15 is the best. So 15.
15 Celsius?
Only a bit colder than
Oh. So yeah, because typical room temperature is 20 to 22 Celsius or 68 to 72 Fahrenheit. 68 being the cool end, 72 being the warm end. A lot of people like it at 70. But anyway, so there's 2 more physical properties that you can add to your notes. Right, Carter Downer?
Mm-hmm.
So there's 2 more things you can add to your notes on physical properties. So 2 more physical properties of substances are their boiling point and their melting point. Yeah, you can just jot that down. In which case, whether we call it the melting point or freezing point, what is happening at that temperature? Whether it's melting or freezing. What is the change that's going on? If we have ice and we've reached the quote-unquote melting point, what change do we see?
Solid physical.
Solid to liquid. Yes, and that is a physical change. So we see it go from solid to liquid if we've got a solid and it reaches the melting point. So at the melting point, that's when a solid turns into a liquid. Or obviously, if it's the freezing point, it's vice versa. A liquid turns into a solid at the freezing point. But obviously, the freezing point or the melting point, they're the same thing. Okay? So just you can make the note that the freezing and melting point are the same thing. It's the same temperature. Okay, because for us, at 32. 32 is our melting slash freezing point. 212 is our boiling slash, I wonder if anyone knows what the reverse term is for going the opposite direction. Because when we're boiling, what do we see happening with liquid water?
Turns into gas.
Turns into a gas. So at the boiling point, that's the temperature at which a liquid turns into a gas, okay? So boiling point is the temperature at which a liquid turns into a gas.
So
Yeah,
it'd be boiling and condensing, right?
thank you, yeah. So the reverse direction would be the condensation point. Temperature at which gas turns back into a liquid, okay? So condensation and freezing, or I'm sorry, condensation and boiling point are the same thing. No, not, bless you. So again, for Callie's writing, for your guys' writing, condensation point, gas turns into a liquid. And obviously, freezing point is liquid turns into solid. Callie, you're doing an awesome job. Thank you for being our scribe. Okay, and just to make that note, for condensation and boiling, what was the Fahrenheit temperature that we said again? 212. Or in Celsius?
Yeah.
Oh, I can't think of it.
Baloney. You're the first one to come up with it.
200. I don't know. It's too hard.
Yeah, now you're saying it's too hard. 100 degrees Celsius, 212 Fahrenheit. So whether it's boiling or condensing, that's the temperature. Okay, melting and freezing, what's the Celsius temperature?
0.
Yep, 0 Celsius. And then, of course, in Fahrenheit, it is 32. That's the magic number. And again, those are the points for water. Okay? For water. Every substance has its own unique boiling and freezing. Whether it's boiling, condensing, freezing, melting, every substance has its own unique temperature for it. Okay? Every single one of those elements on the periodic table has its own specific melting and boiling point. Every single one of them. And then compounds also have their own unique melting and boiling points. That's what makes them pure substances. It has its own unique physical property. Getting back to, how we define pure substances and compounds. Pure substances and, in other words, compounds and elements, they have their own unique physical properties. So water has its own unique boiling and melting point. The two elements that it's made up of, hydrogen and oxygen, they have their own unique boiling and melting points. In fact, oxygen and hydrogen as individual gases have boiling points that are way, way cold. Because right now at room temperature, hydrogen and oxygen exist as gases. We breathe in oxygen. There's also hydrogen gas in the air that we breathe in. We don't use it for anything, but we're still breathing it in. We're also breathing it back out. Most of the air, here's a did you know, most of the air is comprised of hydrogen gas. So most of the actual air that you're breathing in is hydrogen gas. Now, of course, there's enough oxygen gas in there for us to sustain life, but most of what we're breathing in and out is actually hydrogen gas. We just use the oxygen that we need. And there's one last physical property from last unit that also makes a substance very unique. What was that physical property that we were calculating for different substances last unit? Density, yep. So density is our last physical property. Okay? Perfect. Okay, so that's all for physical properties. I'm gonna stop the camera right here, hand out your homework. I'll restart it again to get the lab going.